Hey everyone, welcome back. So in today's video, we are going to try to solve a very special problem based on functional equations and application of derivatives. This problem was asked in IIT JEE 2010 Mathematics paper 2, and this is particularly special for me because it was the year when I also appeared for this examination. Okay, so let's try to see what is the complete question and try solving it. All right, so the question is, let f is a real valued function defined on the interval -1 to 1. This is the domain such that fx satisfies this functional equation given by e raised to the power -x into fx equals to 2 plus a very big integral of square root of e raised to the power 4 plus 1 dt, and the limits of this integral are 0 to x. All right, and again x belongs to -1 to 1. F inverse be the inverse of function of x. So okay, and we have to evaluate f inverse to derivative. Okay, so what do we have to find out the derivative of f inverse x at x equals to 2. We have to keep in mind this is what we need to evaluate, and I will highlight this: derivative of f inverse x. This is what we are interested in. First point in this is that we have to find out the derivative. So that is the first clue how to solve this question. Another clue is the integral part. You see, whenever we have an integral whose limits are functions of x, that is the limits are variables, then always think of differentiating this integral, right? So we have two clues. One is the question itself says that we are interested in finding the derivative, and second clue is that we have an integral term which contains variables in its limits. So let's try differentiating it. What do we get from here? D by dx of left hand side e raised to the power -x fx equals to derivative of 2 plus integral of square root t raised to the power 4 plus 1 dt. The limits are 0 to x. We are going to use Lebanese theorem to differentiate this integral, and I will give you the basic formula of Lebanese rule right here, but for detailed explanation of Lebanese theorem, watch my previous video. I will provide the link in the description. So let me first write down the Lebanese theorem. Lebanese rule says that if I want to differentiate this integral d by dx of integral gt dt such that the limits of this integral are from ax to bx, then this differential is very simple. Substitute the upper limit in the function g, that is g of bx, and then multiply it by the derivative of upper limit. Repeat the same process for the lower limit. So substitute lower limit inside the function g multiplied by the derivative of lower limit. So this is Lebanese theorem, super important, and I have made an exclusive video for this. The link will be provided in the description. All right, let's differentiate now. So the derivative of left hand side is e raised to the power -x into derivative of f. I am applying the product rule here, plus f of x multiplied by derivative of e raised to the power -x, which is going to be negative of e raised to the power -x, equals to, in the right hand side we have a constant term 2, its derivative is 0, and we have an integral term, its derivative is calculated using the Lebanese rule. So in this function I'll substitute the upper limit. We will get square root of x raised to the power 4 plus 1 multiplied by the derivative of upper limit x, which is 1, minus, when we repeat the process for lower limit, you can see that lower limit is a constant number 0, so its derivative is going to be 0, so we don't need to bother to differentiate it. All right, so this is the equation that we have got. Let's try to simplify it a little bit. E raised to the power -x multiplied by f dash of x minus f of x equals to square root of x raised to the power 4 plus 1. We can multiply e raised to the power x on the both sides of equation, and this is what we are getting. This is what we are getting. So we have this equation in terms of derivative of f and the function f. The question is, can we solve this equation? Can we solve this Maybe we can solve it using differential equations, but because of presence of this term square root of x raised to the power 4 plus 1, maybe this differential equation might become a little difficult. Good thing is that we are not really required to find the value of fx. Why do we solve the differential equation if we don't need the value of fx? We just need the derivative of f inverse x. So let's try to think how we can find out derivative of f inverse, given that we have some idea about derivative of f using this equation. First and foremost thing is we need to know what is the meaning of f inverse. So let's say that f inverse of x is denoted by a function g of x. This implies that g inverse of x is fx. Right? The two functions are inverses of each other. If the inverse of f is g, that also implies that inverse of g is going to be f. So I'm going to use this equation. What we can do here is apply the function g or f, any function that you want on both sides. I'm going to apply the function g. So we will get g of g inverse x equals to g of fx. Let's try to solve it. G of g inverse, these two functions are basically going to cancel out each other. We will get x. And here we have g of fx. Right? So g of fx is equals to x. Now take the derivative. Why do we want to take the derivative? Because we are interested in the derivative of f inverse, which is g. So we are interested in the derivative of g dash, right? So take the derivative here and we will get g dash of fx. I'm going to apply the chain rule. First derivative of the outer function multiplied by derivative of the inner function f dash of x equals to derivative of x is going to be 1. If you have any problem in evaluating the derivative of composite functions like this, I'll make a video on this so you can watch that video as well. But this is called chain rule. It's a very basic foundational principle of differentiation. So we have this equation g dash of fx multiplied by f dash of x equals to 1. We are more interested in finding the value of g dash of 2. Right? The original question was find the value of derivative of f inverse at x equals to 2. F inverse, we have named it as g of x, right? So we are interested in finding derivative of gx at x equals to 2, that is g of 2. How do we find out this? So to evaluate g dash of 2, we basically want to find out value of x for which the expression fx evaluates to 2. If fx evaluates to 2, we can very easily get g dash of 2. So let's try to find out how can we find value of x for which fx becomes 2. So we'll go back to the original equation. The original equation was, I think, e raised to the power negative x fx equals to 2 plus integral of square root of t raised to the power 4 plus 1 dt, limits from 0 to x. Now we have to use a little bit of common sense to find out value of x for which fx evaluates to 2. You can very easily see 2 is right here, right? You can see 2 directly. So by basic observation, you can see that if we substitute x equals to 0 in the left hand side, we will be left with f of 0 only. This is f of 0. So we have f of 0 equals to 2 plus for x equals to 0, both the limits of the integration are same, 0 to 0. So the integral will reduce to 0. So we will get f of 0 equals to 2. And this is exactly what we were looking for. We were looking for value of x for which f becomes 2. We have got that value as x equals to 2. X equals to 0, sorry. So x equals to 0 is the value of x for which fx is coming out to be 2. So if we substitute x equals to 0, we will get from here g dash of f0 equals to 1 over f dash of 0. We need to find out value of f dash of 0. We already know the value of f0, which is 2, and this is what we were supposed to evaluate. This is equal to 1 over f dash of 0. Now f dash of 0 is super easy to calculate because we already have a differential equation that we formed here. Yeah, this is the differential equation. So if you substitute x equals to 0 here, we will get f dash of 0 minus f of 0 equals to what did we have in the right hand side? Substitute x equals to 0. First term becomes 1. Second term also becomes 1. So we will have 1 in the right hand side. And from here, f dash of 0 is 1 plus f of 0. We already know that f of 0 is 2. So this is coming out to be 1 plus 2, that is 3. And when you substitute the value of f dash of 0, we will get g dash of 2 equals to 1 over 3. And if you remember, this was nothing but f inverse 2 का derivative. The derivative of f inverse at x equals to 2. This is coming out to be 1 over 3. So this is the final answer that we are getting, and you can see that this was a really nice problem. It involved multiple concepts of calculus. It involved evaluating the inverses, the idea of inverse, that is the basic functions. Then it involved taking the derivative of integrals, that is part of the integration or differential calculus. So basically, this one problem had in it all the basic concepts of calculus involved. I hope you guys liked this video, and if you did, don't forget to like it, share it, and subscribe the channel. Share the video with your friends, and I will see you guys around in the next video. Thank you all for watching. Have a really nice time.